Alright, so we've added, subtracted, multiplied, and divided monomial radicals. What if we have a binomial radical? For example, 1 plus radical 2 times 4 minus radical 3. Well, we're just going to treat this just like we would any binomial. We're going to FOIL it out. Let's distribute the 1. 1 times 4 is 4. 1 times negative radical 3 is negative radical 3. Radical 2 times 4 is positive 4 radical 2. And radical 2 times negative radical 3 is negative radical 6. And now what's unfortunate about this is there's nothing we can do to clean this up. This is a constant with no radical. This is a radical 3, this is a radical 2, and this is radical 6. So it looks real messy, but this is simplest radical form because there's nothing to clean up. Let's say we had radical x plus radical y times radical x minus radical y. Let's FOIL this out. Radical x times radical x is radical x squared. Oh, that was a preemptive plus sign there. Alright, radical x times negative radical y is negative radical xy. Radical y times radical x is positive radical xy. Notice how I put it in alphabetical order so that I can see if these are like terms, which they are. Positive radical y times negative radical y is negative radical y squared. And now I can clean this up. Radical x squared is x. Negative radical xy, positive radical xy cancel out. And square root of y squared is y, so minus y. That looks a lot nicer than the previous example. Sometimes you clean it up, sometimes you can't. Now, this product should look used to you. You should be familiar with it. When you have the same terms in the same order with a different sign in the middle, that was factoring with the difference of two squares. We're just going in reverse now. X minus y, they're not perfect squares, but guess what? They have square roots. Just because it doesn't come out to be a perfect square doesn't mean it doesn't have a square root. So this term is important to recognize, and these are called conjugates. Conjugates are the same terms, same order, opposite signs. So 3 plus radical 2. Its conjugate is 3 minus radical 2. Radical 3 minus 8. Its conjugate is radical 3 plus 8. Notice I didn't change the order. All I did was change the sign in the middle, just like I did with the difference of two squares. So now, this term conjugate is going to be important to divide binomial factors. But before we do that, let's just divide something like radical 48 minus radical 12 over radical 2. So I can divide both of these by radical 2 separately. As long as I'm dividing them both by radical 2, then I can divide them both at the same time. Because when we were adding, subtracting fractions, we were able to say this is radical 48 over radical 2 minus radical 12 over radical 2. That's what a common denominator means. You can separate numerators, can't separate denominators. There's no such thing as a common numerator, only a common denominator. So these I could just treat as two different fractions. Mrs. Fincher would say, if you could make a heart, then you could simplify it, but that's not what I say. But if it helps you, then yeah, you could divide if you can make a heart. Isn't that cute? So radical 48 divided by radical 2, we can just divide the radicands and make it one radical. So 48 divided by 2 is 24, so radical 24. And 6 divided by 2 is 12, radical 6. We still have some simplifying to do. Radical 24 can be expressed as radical 6 times 4. Radical 6 is already simplest radical form. And we could clean that up. Make that 2 radical 6 minus radical 6. So this is a 1 radical 6. Not written there, but there is a coefficient of 1. 2 radical 6 minus 1 radical 6 is 1 radical 6.